Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to control our Arduino robot Wi-Fi car with the help of OpenCV and cvzone hand tracking module. Okay, before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I told you, we are going to control our Arduino robot Wi-Fi car with the help of OpenCV and cvzone hand tracking module. Okay, for that first you need to install the OpenCV, TensorFlow Lite, then mediapipe and cvzone on Raspbian Buster legacy version, the 32-bit version. Okay, I have already created the video how to install all these basic modules on Raspbian Buster. Okay, I will mention the video link, watch video and just install all these basic modules on our Raspbian Buster legacy version. Okay, so for today's session I have created here a repository, and the repository name is Computer Vision Arduino. Okay, so I will mention the link. You need to simply copy the link and we are going to clone our repository inside our OS. Okay, inside our Raspbian Buster. So go to the code, copy the link and minimize browser, open terminal, and we are going to clone the repository. So command is what? Sudo git clone, and we need to simply paste our link and just hit enter. Okay, it will clone the repository. Now we need to change our owner for our repository, because by default it is belong to root user and we are working with our Pi user, so we need to change the owner and user for our repository. So we are going to change the owner. So sudo chown space -R, Pi is the user and Pi is the group, like this way, Pi:Pi space, and we need to mention our repository name, which is the Computer Vision Arduino. Just hit enter. Now we successfully change our repository owner. Now first, before we start our practical, I just want to explain the concept, what basically we are going to do in today's tutorial. Okay, so we are going to open our repository, so Computer Vision Arduino, and inside that I have created a diagram. Okay, so cloud mqtt.jpg, this is what our image. As you can see, this is the image, and this image is basically explain what basically we are going to do. Okay, so this is what our Raspberry Pi, and this is what our car, which basically connect with our Esp8266, the nodemcu, and we are going to use here our Arduino software, Arduino IDE. Okay, also the Raspberry Pi 4 is basically our publisher, the MQTT publisher. Okay, it will publish the message, and our Esp8266 Arduino is basically the subscriber for particular topic. Okay, and we have here our cloud MQTT broker, a free cloud MQTT broker, which basically available on our cloud. Okay, so it means we are going to create here a two different network. Okay, so our Esp8266 means our Wi-Fi car, which we are going to connect with our mobile hotspot. I have here a Geo network. Okay, Geo mobile network. So I am going to connect the Esp8266 with mobile hotspot, and our Raspberry Pi 4 is basically connect with the router. Okay, so the router is basically a different network, and the mobile hotspot, it's basically a different network, two different network connection, and we are going to create the communication in between these two different network with the help of internet, and we are going to use here a cloud MQTT broker server. Means we are going to use here our cvzone hand tracking module. So we are going to create the condition, like say when one finger is up, the publisher will be send the message on our Esp8266, which is a subscriber. It will send the message, it will send the forward message, means motor will be moved forward. Okay, so this is the concept. This is how we are going to create the communication in between two different network with the help of internet and with the help of our cloud MQTT broker. Okay, so this is what our concept. Okay, so now we are going to start our practical. First we need to install Pi apps, because we need here our Arduino software. Okay, Of course you can use the Windows machine also. I have already created the video how to install Arduino on Windows machine, also how to configure Esp8266 with Windows machine. I will mention this in the video link. Watch video and just install IDE and configure the Esp8266. That's it. So in today's session we are not going to use here a Windows machine for Arduino. We are going to use here our Raspberry Pi 4 machine with Raspbian Buster legacy version, okay, the 32-bit OS. So simply first we need to download here Pi apps, okay. So I have created here a text file and the text file name is rpi app. Simply open with text editor and this is the first link. As you can see, install Pi apps. We need to simply copy the first one link, copy it, open terminal, and we are going to simply paste link inside the terminal and just hit enter. It will automatic install the Pi apps on our Raspbian Buster. Okay, I have already installed. Okay, let me show you. As you can see, the Pi apps. So I have already installed. You need to simply copy the link and paste link and just hit enter. That's it. It will automatic install Pi apps. Okay. After that, we need to move inside the menu, then accessories, then Pi apps, and it will open the Pi apps. Okay. As you can see, this is what our Pi apps. Then click on all apps, and here we are going to install the Arduino software. So as you can see, Arduino, click on it and it will open the Arduino. So as you can see, Arduino install, because I have already installed, that's why it says the install. You need to simply click on here and it will install Arduino IDE on our Raspbian Buster legacy version. Okay, it will automatic install. Okay, then now we have our Arduino IDE software. So simply go to the menu, programming, and as you can see, we have our Arduino IDE. But we are not going to open it from here. We are going to simply open our sketch directly from our repository. Okay, so computer vision Arduino repository again, and as you can see, mqtt-moto.ino. This is what our sketch. So right click and just click on open. It will automatically open from our Arduino software. Okay, so as you can see, it's opening. So friends, as you can see, meanwhile it asks us to click on OK, because it says the file mqtt-moto.ino needs to be inside a sketch folder named mqtt-moto. So we need to simply click on OK, and as you can see, we have successfully opened our sketch from our Arduino software. Okay, so first what we want to do, we want to install the Esp8266 driver on our Arduino IDE software. Okay, so again we are going to open our text file, which is the rpi app, and this is the link for our Esp8266. As you can see, I have mentioned here Esp8266 link. So again we need to copy the link, just copy it and minimize the text editor, and we are going to open the file preference. Okay, and then we need to simply paste the link inside the additional board manager URLs. Okay, so as you can see, I have already pasted the link, so I'm going to delete the link, and here we have copied the link. We need to simply press the Ctrl+V from our keyboard. That's it. As you can see, it pastes the link. Then we need to click on OK. Okay, now we need to again go inside the tools, and then we need to go inside the boards manager. The same action what we always do for installing the Esp8266 driver on our Arduino IDE, same action. Okay, and here we are going to search for our Esp8266. Okay, and friends, then as you can see, we need to search for here Esp8266. Okay, and Esp8266, as you can see, I have already installed the driver. Okay, so you need to simply click on here, okay, install, and it will install Esp8266 driver. That's it. Now what we want to do, we need here one more library, which is the pub/sub client. As you can see, I have mentioned here a pub/sub client. So we need to install the pub/sub client. So go to the tools and manage libraries, and it will open the libraries window. Okay, and friends, as you can see, the library manager window is open, and here we need to search for pub/sub library. As you can see, I have mentioned the pub/sub library. Just hit enter, and then we need to scroll down here. Just scroll down, scroll down, scroll down, scroll down, and here as you can see, the Nick or Larry. this is the pub/sub client library which we want here, okay, which we basically want to install. So I have already installed, as you can see, pub/sub client Nick O Larry. Okay, so click on here and it will install the pub/sub client. That's it. So we have done with installing and enabling ESP8266. Now we need to connect our ESP8266 with Raspberry Pi 4. So just connect the ESP8266 with Raspberry Pi 4 using our USB data cable. So I have already connected. Okay, then again go to the tools. In board we need to go here, ESP8266 boards, and just scroll down here and we are going to select this board, nodemcu 1.0 ESP12E module. So selected our board. Again go to the tools and this time we need to select basically the port. So port, and inside the port we need to select /dev/tty USB 0. This is what our port which we want to select. So select it, port. That's it. So we have done with installing libraries. Also we have select our board, also we have select our port. That's it. Now what we want to do, as I mentioned here as you can see the SSID, this is where you need to mention your mobile hotspot ID, means SSID, the mobile hotspot name, and here you need to mention the mobile hotspot password. Okay, so I am going to mention here my mobile hotspot name, which is the OpenCV, and the password is basically freedom tech. Okay, and mqtt.flux.io. this is what our online cloud MQTT server, the MQTT broker. Okay, so don't change the server name, okay, because we are going to use this server for our testing purpose. This is the free cloud MQTT broker server. Okay, mqtt.flux.io. okay, then scroll down. This is how I have connect the ESP8266 with L29810 DC motor driver board. Okay, so iron 1, iron 2, iron 3 and iron 4. Let me show you the diagram for the hardware connectivity. So handcar.jpg, this is what the image. As you can see, this is how we need to connect our ESP8266 with L29810 DC motor driver board. Okay, so here I have mentioned the pins, the ESP8266 pins and the L29810 DC motor driver board's pins. So ESP8266 D2 pin which we want to connect with the iron 1, the L29810 pin, then D1 which we want to connect with the iron 2, and then D7 which we want to connect with the iron 4, and D6 which we want to connect with the iron 3. Okay, so I have mentioned the connectivity, how you need to connect the ESP8266 with L29810 board. Then the battery, so plus goes here in first connection and the ground, it goes here in second connection, the second port and the first port. So live goes here first port and the ground goes here second port. Also we are going to use here our battery for powering our ESP8266. So Win pin which we want to connect with the first port where we connect our battery live connection. Okay, as you can see the Win pin I have connect, the Win pin wire I have connect with the first port which is our live connection, and the ESP8266 ground, as you can see the ground I have connect here in same connection where we connect our battery ground. Okay, so this is how you need to connect the ESP8266 with L29810 and the battery with L29810 board. Okay, I hope you all clear. Now we need to simply install the sketch inside our ESP8266 board. So simply we are going to click on upload, and now it will upload the sketch inside our board. Okay, so friends, as you can see our sketch is uploading inside our ESP8266. Okay, 46, 53%, 61, 100%. That's it. As you can see we have successfully uploaded the sketch inside our ESP8266. So we have done with our Arduino side. Now we are going to open our hands.py from our Thony Python ID. Okay, so let me minimize the Arduino software and we are going to open the programming Thony Python ID and go to the file, click on open. Again we need to go inside our repository, so py, and here we are going to search for computer vision. So computer vision Arduino, this is what our repository, and hand.py. Okay, click on OK. So I have already created a video how basically we use the cvzone for hand tracking. Okay, so I'm not going to explain all these things again. So watch the video. I will mention the video link, watch video, and you will get the basic idea how to use the cvzone for hand tracking. Okay, here as you can see, I have created here a function, the forward function, and the same server which we want to mention, because our Raspberry Pi 4 is basically publisher. So same server mqtt.flux.io. Then this is what the name, and this is what the topic. The test2 is basically topic which basically subscribe by our Esp8266. So test2, and this is the message. If the condition is completed, then it will send the forward message on our Esp8266, and then robot will be moved forward. Okay, then back message, then the turn message. Okay, as you can see, turn message and the stop message. Okay, then if I scroll down, okay, so this is the basic concept which I have already explained inside the cvzone. Okay, so let me start the code and then we will get the idea. Okay, so friends, as you can see, I have started the frame, and right now there is no hands. Okay, so 5 finger is up, action is stop. As you can see, the 1 finger is up, action forward, 2 finger up, action back, and 4 finger up, action will be turn. Means our Wi-Fi car will be move turn. Okay, so 1 finger up, Wi-Fi car will be move forward, 2 finger up, Wi-Fi car will move back. If I show 4 finger up, it will make turn, and if I show 5 finger is up, it will make stop. Okay, so this is how we can use a cvzone hand tracking module for controlling our robot Wi-Fi car. Okay, so now we have all done with coding side. Now we are going to see a live demo. Okay, so friends, as you can see, this is what our chassis, the battery pack, and our L2910 DC motor driver board. Okay, so I have connect all the wires as I mentioned in the diagram. Okay, you can use here any chassis. Okay, so connectivity is same as I mentioned inside the diagram. Okay, now we are going to see the practical action. Okay, so friends, as you can see, right now 5 fingers is up and car is stopped. If I show 1 finger, car will be moved forward. Again 5 finger up, it's stopped. If I show 2 finger up, it's moved backward. As you can see, again 5 finger up, it's stopped. If 4 finger up, the action is turned. As you can see, 4 finger, action is turned. Again 2 finger, back. Stop. 1 finger up, the action is forward. Again 4 finger, it's make turn. Okay, so this is how, friends, we can control our Arduino Wi-Fi car with the help of OpenCV and cvzone. I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.